This is the last of the narrated formula PowerPoints for exam 2. Yes, I can hear you all cheering. Really, I can. And fortunately, this one is a relatively simple equation, the event horizon for a black hole. Now, the event horizon for a black hole is how close you can get before you get completely sucked in, not even light can escape. And the event horizon is also called the Schwarzschild radius, named after Karl Schwarzschild, who came up with it. So here you can see that the Schwarzschild radius, r equals 3 kilometers times the mass divided by the mass of the sun. So this is going to be in solar mass units. So it's 3 kilometers for every solar mass. So a typical problem might be, what is the size of the event horizon of a 7 solar mass black hole? Well, we know that the Schwarzschild radius is going to be 3 kilometers times the mass in solar mass units. Is the mass in solar mass units? Yes, thankfully. So we just take 3 kilometers times 7, because the mass is solar mass units, and we end up with 21 kilometers. If you were to come within 21 kilometers of this black hole, you would be hopelessly sucked in, never to be seen again. But you can also do more fun problems, like what is the size of the event horizon of a black hole the mass of an elephant? Well, first we need to know the mass of the elephant, and I looked it up online, and it apparently depends on what kind of elephant you're talking about. So I decided to go for the heavier elephant, and the mass is 3,000 kilograms. Now remember that we need to put this in solar masses. So what is the mass of an elephant in solar masses? So an elephant has a mass of 3,000 kilograms, and we know that one solar mass is 1.99 times 10 to the 30th kilograms. We see here that kilograms is going to cancel, and so our answer is going to come out in solar masses. So let's all grab our calculators and divide this out. 3,000 divided by 1.99 times 10 to the 30th comes out to be a very tiny number, 1.51-ish times 10 to the negative 27th. So the event horizon, or Schwarzschild radius, for an elephant-massed black hole is 3 kilometers times 1.51 times 10 to the negative 27, because that is the mass of the elephant in solar masses. So now take this answer, the answer we got before, multiply it by 3, and we end up with the event horizon for this elephant-massed black hole to be 4.52 times 10 to the negative 27 kilometers, which is really freaking tiny. It's tinier than the size of the atom. So if you wanted to take an elephant and turn it into a black hole for some really strange reason, like if you were Dr. Horrible or something, you would have to squish that elephant down, so it would be this incredibly tiny distance. Let's not actually do this experiment, okay?